Hi, everyone. In section 8.4, which is required, definitely, we're going to talk about the determinant of a square matrix, which is usually a number that we associate with a square matrix. And later on, we'll talk about its applications to area and volume. So every square matrix consisting of scalars, in particular real numbers, has a determinant. And we can denote that by det of A, or A with the double bars around it. Again, the determinant is a scalar or a real number. Now, some people might confuse these with absolute value. It does not mean absolute value because, for example, determinants can be negative. So if you find this confusing, use det of A. We're going to start with talking about shortcuts for computing determinants. And by the way, determinants, as far as they go, the key question is whether or not they're zero. Or maybe they're close to zero. Basically, if a determinant is close to zero, things are kind of messed up. All right, some shortcuts. Well, not surprisingly, if you have a 1-by-1 matrix, like this thing, the determinant will be the entry. So if A is the matrix consisting of 7, the determinant of A would be 7. This is where the absolute value confusion can come in, because if, for example, the entry is -7, then the determinant would be -7. But this might look weird to some people. If the matrix is 2-by-2, you get the determinant by what I call the butterfly, the product along the main diagonal minus the product along the skew diagonal, AD minus BC. Now, the shortcut for 3-by-3, this is given in some books, but not all. Sarris's rule, named after Pierre Sarris, actually. So for a 3-by-3, this seems almost random, but the rule is that you take the matrix, you write the first and second columns over to the right as columns 4 and 5. And then you do this. Well, maybe I'll do a duplicate. Yeah. Okay, so we're going to add the products along the 3 full diagonals that extend from upper left to lower right. So here's a template: plus sign, parentheses, plus sign, parentheses, plus sign, parentheses. I arrange it so that when you multiply down each of these, or down or up each of these diagonals, then you put the product inside the parentheses. Over here for the blue, again, you put the product along the line inside parentheses. So we add the product along the 3 full diagonals that extend from upper left to lower right, and we subtract the products. That's why we have the minus signs here, along the 3 full diagonals that extend from lower left to upper right. In order to remember that you subtract these products, that's why we put the minus signs in the templates. So after you get this template down, it's very easy. You take the product along each diagonal and put it in parentheses. Your only danger is an arithmetic error, a mechanical error. Okay, so this example, it was this one, all right? If A is the 3-by-3 matrix here, find the determinant of A. In other words, find this. And it's okay, if you're finding determinants, it's okay to write it like this without the brackets inside. This is okay. So again, according to Sarris's rule, you rewrite column 1 as column 4 and rewrite column 2 as column 5. This is what I showed before. You add the products along the 3 full diagonals this way, subtract the products along the 3 full diagonals this way. So within each pair of parentheses, you put the product along the corresponding diagonal. Right here, -1 times 2 times -1 is a +2 in there. This is easy. If you have a 0 on the diagonal, automatically the product is 0. Over here, -2 times 3 times -1 is +6 in there. We add these 3 products. The template does that for you. Over here, 0 here, that means the product 0. Over here, -1 times 1 times -1 is positive 1. Over here, negative 1 times 3 times 1 is negative 3. And then be careful as you unravel the signs. 2 plus 0 plus 6. And then, of course, you can ignore the 0. Minus 0, which we can ignore. Minus 1, minus 3. I'm sorry, plus 3. This becomes a plus 3. That works out to 10. A number. A determinant is typically a number. If the matrix is full of numbers, then the determinant is a number. Which here would have applications for volume, as we'll discuss later. Next up, the method you may have learned back in your old algebra class, finding determinants by the expansion by cofactors method, sometimes known as the expansion by minors method. Next time, try to remember.